Hello friends, welcome to lecture number 10 of complex analysis. In the last lecture, we have already discussed about integration of a function of complex variable. Today we're going to solve one more problem based on this topic. That question also will be taken from HKDA's mathematical physics book. So if you are new to my channel, please subscribe the channel, support me to create new contents for you, and also help me to grow my channel. And here you see, don't forget to hit the bell icon and subscribe. Okay, so do subscribe and hit the bell icon so that you get notified when new video will be uploaded, and also hit the thumbs up buttons and share with your friends. Okay, and here you see, this is my Insta ID. You can follow me on Instagram. Okay, so now let's start. So let me take the question. So here is the question. We need to evaluate this integral along this curve and then along this line joining these two numbers representing the joining these 2 points representing these two complex numbers. Okay, so now let us start this. So first let me write the given function here fz. Here fz, the function is this one, right? Twice x plus iy plus 1, right? And we are to evaluate this. We are to evaluate integration fz dz, that is from 1 to minus I, from 1 minus I to 2 plus I, right? So that's what we need to do, that is integration minus 1 minus I to 2 plus I twice x plus iy plus 1 dz. We need to evaluate this, right? So here you see, we can say z here. Z is nothing but, it is a complex number x plus iy. Z is x plus iy. So we need to evaluate this along this curve. X is equal to t plus 1 and y is equal to 2t square minus 1. So here you see, x is equal to from here t is equal to, we can write x minus 1, right? If that is the case, then if you put the value of t here, then you're gonna have y is equal to 2 into x minus 1 whole square minus 1. And if you simplify this, then you're gonna have, if you expand this using a plus b whole square formula, a minus b whole square formula, then if you subtract it by 1, multiply it by 2, then you're gonna have 2x square minus 4x plus 2 minus 1, and that's gonna give you this, right? Sorry, that's gonna be plus 1. So this is the value of y that we're gonna have, right? This is the value of y, right? So this is the value of y. Now we're gonna replace this y by this value of y, right? So just put this value here. Okay, then from here we're gonna relate dz and dx. Okay, so how to do that? Just to wait. Here you see. Now let me copy these things. Let me go to the next slide. Okay, so here you can see this is the solution of the problem. So here you see, so what we have here, we have z is equal to x plus iy. So let me write here x plus iy. Now z is equal to x plus iy. So x plus iy, y can be replaced by this value of y, right? This y is replaced by this value of y. Then what we're gonna have, that is twice x square minus 4x plus 1, right? So now let us find dz by dx. If we differentiate with respect to x, then what we're gonna have, if you differentiate x, that's gonna be 1 plus I. So here twice x, sorry, it's gonna be 4x, right? Then minus 4. Okay, So differentiate this with respect to x. So I hope you understood this derivative. Okay, if you differentiate this, that's going to be 2x, right? 2x into 2, that's going to be 4x, right? And if you differentiate x, that's going to be 1 into 4, this is 4. Derivative of constant is 0. So hope you have understood this. So I don't think I need to explain. Okay, so if you simplify this, then what you're going to have, dz is equal to 1 plus I 4x minus 4 into dx. Just wait. Now from here we're going to have del z is equal to, so this into not del z, dz is equal to, so let me write here this one, dx. That's what we're going to have. Okay, now therefore it becomes, so integration of minus 1 minus I to 2I, that is twice x plus iy plus 1 dz, that's going to be equal to, here what we're going to do, we're going to replace this y by this expression and dz by this expression. Then what we're going to have, so then we're going to have, let me write this one. So this is what we have got. What we have done, we have replaced this y by this expression and we have replaced this dz by this expression. So this y is replaced by this value, right? And so we have got this. Okay, we have got this expression. Just okay, just I forgot to write this one here. Just let me do one more thing. There should be a bracket here. Okay, so this dx should be outside the bracket. So this is the dx. That's what we have got, right? So now you see, let me copy this one and then let me go to the next slide. Okay, let me go to the next slide. Let me take a new slide here. Now you see here, you can see clearly, as we have replaced the terms y and these terms, as we have replaced y, we have expressed the y in terms of x, right? That's why here you see, this is the complex number I minus 1 minus I, and the corresponding point representing this complex number is 1 comma minus 1. So here 1 is x, okay, and this is y. Similarly this one 2 plus I, the point representing this is 2 comma 1. You can consider I is I into 1, right? 2 comma, this is x and y. So here we can consider that we are integrating it from x1 to x2 like that. So here 1 2 2, because we have expressed the y in terms of x, right? So hope you have understood these things. So now let's multiply and integrate. So now you see, if we multiply and simplify this expression, then what we're gonna have. So I'm not gonna show all the expressions how I have done, just multiply and I will give you the final expression. If you need it, each and every step, then just send a message via Insta. Okay, I'm going to give you the picture of that rough page where I have done the simplification. Okay, so otherwise it's going to be very long. So being the student of BSc, hope you can simplify this. Okay, just you need to multiply all the terms and whatever you can do, addition, subtraction, by simplifying this expression, which one we are going to integrate. So that is nothing but this one. So this is the final step, right? So hope you can simplify yourself these things. If you can't, then send me a message via Insta. I'm gonna give you the picture of that simplification where I have done. Okay, so now you see, if you integrate this, so first integrate this one, then you're gonna have x to the power 4 by 4 here, 8 into x to the power. So we are integrating it from 1 to 2. Then next term, so if you integrate this, then you're gonna have 24 into x to the power 3 by 3. So we are integrating it from 1 to 2, then minus 18 into x. If you integrate this, then x square by 2. We are integrating it from 1 to 2 again. Then 5 into dx, that's going to be 5x. And we are again integrating it from 1 to 2. Then plus i into 10x square dx. So that's going to be 10x cubed by 3. We are integrating it from again 1 and 2. Then minus I into 8x minus 8x, sorry, I into 8, and x dx. If you integrate it, x square by 2. Then from 1 to 2. Then minus 3, here I into 3, right, dx. So if you integrate dx, that's going to be x simply. So we are integrating it 1 to 2, right? So hope you have understood this. Now let's what we can do here. So it can be cancelled, and we're gonna get here 2. So 3 8s are 24, 2 9s are 18. Then is there anything we can cancel? Okay, here is the another term, here is another term. So is there anything? No, nothing. So then what we're going to have, minus 2 into, then put the upper limits and lower limits. Then what we're going to have, 2 to the power 4 minus 1, 2 to the power 4 minus 1, and that's going to be 2 to the power 4 is 16 minus 1, that's going to be 15, right? So directly we can write 2 into 15. Then plus, here you see this is 8, and 8 into 2 cube minus 1. 2 cube is 8, 8 minus 1, that's going to be 7. So 8 into 7, let's put 8 into 7, then minus, so 9. Here if you put 2, then you're going to have 2 square, minus if you put 1, then 1 square, that is 1. 2 square is 4, 4 minus 1, that's going to be 3. So it's going to be 3. Similarly, putting all of the putting upper and lower limits in all steps, in all the terms, what we can find, we're going to have this one, that is nothing but again 5 only, 5 into 1, right? Then plus I into 10 into 7 by 3 from this term, right? We have got this one. Then from this term, what we're going to have, minus I into 4 into 3, then minus I into 3 into 1. From this term we have got I into minus I into 3. Copy this result and let me go to the new slide. Okay, so here we have got this. So now if you do the calculation, then it's going to be minus 30 plus 56, right, minus 27 plus 5, then plus taking I common, then 3 is LCM, then 70 minus 36 minus 9. So then here you're gonna get 4, then I 25 by 3. That's what you're gonna have. So hope you have understood this. Now again, one more part of the equation is there, one more part of this question is there. So we have integrated it along this curve, x is equal to t plus 1, y is equal to 2t square minus 1. Okay, now we are to integrate this along the line joining 1 minus I and 2 plus I. Okay, so here is the question. You can see that this is the question. Now we need to integrate along this straight line joining these 2 points. Okay, so now let me go to the new slide. Now let us solve the second part. So we are to integrate along this straight line joining these 2. So now you see, so how to do that? First we're gonna find the equation representing this line. So here you can see that first just wait, let me write the equation of the line first. Let me write the solution here. Solution. So here the equation of the line, you can write this one as f of z, right? Integration of f of z, just wait, integration of f of z dz, right? You can write that way, from 1 to minus 1 I to 2 plus I, right? Just wait, 1 minus I 2 plus I, so you can write that way. So equation of the straight line joining 1 minus I and 2 plus I. Now you see the point representing 1 minus I, okay, that is 1 comma minus 1. So take that one as x1 y1. Then point representing 2 plus I, that is 2 comma 1. You can consider this number as 2 plus I into 1, so that's why 2 comma 1. So hope you have understood this. So now let us take this one as x2 y2, and the equation of a line joining x1 y1 and x2 y2 is given by y minus y1 is equal to y2 minus y1 divided by x2 minus x1 into x minus x1. If we apply this formula, then we're gonna get the required equation, that is here y minus y1 is considered to be minus 1 here, so that's going to be plus 1 here, because here you see minus this, that's going to be plus 1, right? So then y2 minus y1, that means 1 minus minus 1, so 1 minus minus 1, that's going to be plus 1, right? So 1 plus 1 divided by x2 minus x1, so x2 minus x1, 2 minus 1, right? So 2 minus 1 into x minus x1, x1 is here 1, so that's why 1. So this is the equation. If you simplify this, then what you're gonna have, you're gonna have this, right? 2 in by 1 means 2 and x minus 1, and if you multiply this, then it's gonna be twice x minus 2, and if you take this plus 1 on the other side, that's gonna be minus 1. So that's why it becomes twice x minus minus 3, right? That's what we have got, y is equal to this one. Then again you see here f of z is, in this case this is the f of z, right? That is twice x plus I y plus 1, and here z is equal to x plus I y, right? Now let's put the value of y here. Then what are we gonna have? X plus I, y is twice x minus 3, right? So here, now here you see x plus I twice x. Just let me do one thing. Now let us differentiate this, del z by del x. So then it's gonna be 1 plus I, 2 into x. If you differentiate this, then it's gonna be 2 only, so that's what we have got. So dz is going to be 1 plus I2 into dx. So here now 1 minus integration 1 minus I to 2 plus I, here twice x plus I. Let us replace this y by this value of y, not this one, this one, let us put here. Then what we're gonna have, I into twice x minus 3 plus 1, right? Then here you see, let's replace this dz by this value of dz. Then what we're gonna have, then we're gonna have 1 plus I into 2 dx, right? So let me use here curly bracket. So just wait. Okay, that's what we have got. Now do one thing, just multiply and simplify this expression, then integrate. Okay, so what you're gonna have after simplification, let me write the final result that what we're gonna do. So here what we are going to do, we can express this one in this way, that integration I minus 1 minus I to 2 plus I. So let me write the real part as real part separately. This one plus 1, this is the real part, right? Then the imaginary part is this I twice x minus 3, then integration into 1 plus I into 2 dx. Now let me take this, let me copy this step and let me go to the next slide. Right. So here you see, this is what we have got. So I into 2, you see, integrating. So now you see, you can write here it is from 1 to 2 simply because we have replaced we have expressed y and z in terms of x only, so we can take the real part of these two. Okay, so that's why from 1 and 2 we can integrate. So if you multiply and simplify this expression, then you can have this result. So let me write that one, just do it. Let me write it from 1 to 2, you can write it. So then what we're gonna have after multiplication and integration, sorry, not integration, after simplification, we're gonna have twice x plus 1 minus 4x plus 6 dx plus I integration 1 to 2 4x plus 2 plus twice x minus 3. Okay, so what we have done, we have multiplied this one with this and this one with this, then we have separated the real and integral part, real and imaginary part. So now let's simplify. If you from here, what you're gonna have, that's gonna be minus twice x plus 7, and here it's gonna be 6x minus 1, right? So that's what we're gonna have. So it can be written as integration 1 to 2, so minus twice x plus 7 dx plus I into integration 1 to 2 6x minus 1 dx. Now let us integrate this. So integrating minus twice x, we're gonna have 2x squared by 2, right, from 1 to 2, then plus 7 into dx, integrate dx, so it's gonna give you x. So from 1 to 2, then plus I integration of 6x, that's gonna give you 6 into x squared by 2 from 1 to 2, then minus 1 into dx, integrating dx, we're gonna have x from 1 to 2, right? So now here you see, so I forgot to multiply this I, so here it should be I into 1i, right? Now let me copy this and let me go to the next slide. Okay, that's very simple, right? So this is the last step we have got, and if you calculate all these things, it's gonna be cancelled, and here it's gonna give you 3, and put the upper limit, then minus lower limit. Okay, then put here, then what you're gonna have, so here minus 2 square minus 1, that's gonna be 3, right? When you put upper limit, then you're gonna get 2 square. When you put lower limit here, then you're gonna get 1 square, right? That's very simple. You know these things already. Okay, that's gonna give you what, minus 3. Similarly from here, you're gonna have 7 into 2 minus 1, that's gonna give you 7 only, right? 7, then plus, so from here 3 into 2 minus 1, that's here you see 2 square minus 1, that's gonna be 3 into 3, so it's gonna be 3 into 3, and we have the I here, then minus here I into 2 minus 1, that's gonna be I simply, right? So 9i minus 1i, that's gonna be 8i, right? 8i, and 7 minus 3, that's gonna be 4. So this is our answer. So hope you have understood. So if you have understood, please share with your friends, help me to grow my channel, inspire me to create new contents for you, and stay connected. Hit the thumbs up button, hit the bell icon, hit the subscribe button as well. So see you in the next video. Thank you.